Assalamu alaikum. My name is Moaaz Ahmad, and in this video, I'm going to explain the question number 1 and question number 2 of our DLD assignment number 3. So, first, I will explain the question 1, in which we were required to design a 4-bit ALU. ALU basically stands for Arithmetic Logic Unit, and in this question, we were required to design such a circuit using ICs that could perform the basic arithmetic logics like addition, subtraction, multiplication, or division. So I have built it in my Proteus software. So now if I open my Proteus software here, you can see that the components I am using for my circuit are these, and here is the keypad to give input to our circuit, and this is our quarter circuit that converts the keypad input to BCD, and this circuit is basically dependent on principle of delatching circuits. So in this circuit we are using two circuits, delatching circuits. One is right here and the other one is here. So both of these latching circuits are for each input. This one is for first input and this one is for second input right here. Now here you can see that this circuit is used for addition or subtraction. When this is 0, this circuit will give us the addition, and when this is changed to 1, and then it will give us the subtraction. And same is the case with multiplication right here. This circuit will give us the multiplication. Now if I run my circuit, I can see that if I add some input here, let's say I want to add 5, then this will not be added automatically to my circuit. So to add this as my first input, what I have to do is make this circuit high. So I will change it from 0 to 1, and now you can see that 5 has been added as our first input. Now to add our second input so that we could perform arithmetic operations on them, I will change it back to 0, and let's say I want my second input to be 2. So I will change it to 2, and now to add this as my second input, the same thing that I did before, I have to do it again, but this time with this latching circuit. So I will change it to high, and you can see that the second input has been added. So I can see here that since it is 0, it is showing me my addition answer, which is 5 plus 2 is equal to 7. So if I want my subtraction answer, I can do is I can change it to 1, and see it is showing me 5 minus 2 is equal to 3. And if I try with something else, say I want my first input to be 2, 2, and I add it as my first input, and the other thing that I want is the second input to be, let's say, 4, and I change it to 4. Now you can see that here if I change it to addition, you can see that it is showing me my addition answer, which is 4 plus 2 is equal to 6, and here it is showing me my multiplication, which is 4 multiplied 2 is equal to 8. So that's it from this side question. Now coming to the question 2, we were required to design a 4-bit combinational circuit by the means of a 4-bit binary adder. The overall problem was divided into two stages. In the first stage, we were required to design a combinational circuit in such a way that when an input is provided and the input provided is an even number, 1 is added to that number in order to make it odd. And when odd number is provided as input, then nothing adds to that number and the output will be same as the input. So for example, 4, which is an even number, when it is determined that it is an even number, then 1 will be added to 4 and the output will be 5. But whenever an odd number is detected like 7, then output will be the same as 7. Now in the second stage, as we can see here, for example, if 0010 is the input, which is 2 in decimal, which is an even number, then output from the first stage will be 0011, which is equal to 3. So we can see that in the first stage 1 is added to the inputs, and same is the case with the other integer, which is an odd integer 0011, which is equal to 3 in decimal. And we can see here in the first stage output that the output for this number is 0011, which is same as the input. And now coming to the second stage, in the second stage we simply shows what was provided as input. As we can see here, since the input was 0010, we can see that the second stage output was also 0010. So we can assume that in the first stage 1 is added to the input, but in the second stage 1 is subtracted from the first stage. So this acts as subtractor and this one is added. Now if I go to my Proteus circuit and run this file, now you can see that if I give it one value, it is showing me that my input is 1, and in the first stage my output is also 1 since it is an odd number, so 1 will not be added to it. And this is my second stage, which is same as this input. And if I change the input to 2, now input is 2 and the second stage is also 2, but the first stage is 3. The reason is that since 2 is an even number, that's why 1 is added to it and it becomes 3. Now if I change the input to something else like 5, then you can see that the input is 5. The first stage is also 5 since it is an odd number, so 1 will not be added, and output is also 5 from the second stage. So that's it from this circuit. Allah Hafiz.